When scientists designed the James Webb Space Telescope, they had a clear goal in mind. They wanted to look farther into space than ever before. Because light takes time to travel, looking farther away also means looking further back in time. Every distant galaxy is a snapshot from the universe's past. The most remote objects reveal what the cosmos looked like billions of years ago, shortly after the first stars began to shine. Researchers expected these ancient galaxies to appear small, irregular, and unfinished. After all, the early universe was supposed to be a place of beginnings. Galaxies should have been slowly growing, gathering matter through gravity, and gradually evolving into the enormous structures we see today. But when the James Webb Space Telescope started sending back its first deep observations, something unexpected happened. The earliest galaxies didn't always look young. Some appeared surprisingly bright. Others seemed unusually large. A few looked far more developed than scientists anticipated for such an early period in cosmic history. Suddenly, astronomers were confronted with a fascinating question. Had galaxies formed faster than current models predicted? The discovery did not overturn modern cosmology. The evidence supporting the Big Bang remains strong. The expansion of the universe is still observed. The overall picture of cosmic evolution continues to explain a vast amount of data. Yet Webb's observations suggested that some details of the story might be more complicated than previously believed. To understand why this matters, it's important to understand what Webb actually sees. Unlike many earlier space telescopes, Webb specializes in infrared light. As the universe expands, light from distant galaxies stretches into longer wavelengths. Objects that once emitted visible light billions of years ago now appear primarily in infrared wavelengths. This makes Webb uniquely suited to studying the earliest periods of cosmic history. In a sense, the telescope functions like a time machine. Every image it captures contains information from a different era of the universe. The farther away an object is, the farther back in time we are seeing it. When astronomers analyzed some of Webb's deepest observations, they found galaxies that appeared unexpectedly energetic. These systems were producing tremendous amounts of light. In astronomy, brightness is more than a visual characteristic. It provides clues about what is happening inside a galaxy. A bright galaxy may contain enormous numbers of stars, intense star formation, or energetic activity surrounding a central black hole. The challenge was that some of these galaxies seemed to exist very early in cosmic history. According to many models, there should not have been enough time for them to grow so quickly. Naturally, scientists approached the findings with caution. Extraordinary observations require careful verification. Distance estimates had to be confirmed. Spectroscopic measurements needed to verify how far away the galaxies truly were. Researchers also considered alternative explanations. Perhaps some galaxies appeared brighter because they were experiencing explosive bursts of star formation. Perhaps supermassive black holes contributed additional light. In some cases, gravitational lensing could magnify distant objects, making them appear larger than they actually were. Astronomers spent months testing these possibilities. Many observations were refined as new data became available. Yet even after extensive analysis, an intriguing pattern remained. The early universe seemed more active than expected. Instead of a slow and quiet beginning, the cosmos may have experienced periods of rapid growth shortly after the first stars formed. This possibility has inspired several ideas. One explanation suggests that the first generations of stars may have formed earlier than scientists predicted. Another proposes that young galaxies converted gas into stars with extraordinary efficiency. Some researchers believe supermassive black holes may have appeared sooner than expected, helping shape galaxy growth during the universe's earliest chapters. Others point toward the role of dark matter. Although invisible, dark matter provides the gravitational framework upon which galaxies form. If matter collected more efficiently inside dark matter halos, early galaxies could have matured faster than previous simulations suggested. At the moment, no single explanation has solved the puzzle completely. That uncertainty is not a problem. It is one of the most exciting parts of science. Throughout history, major discoveries have often begun with observations that challenged expectations. When astronomers first discovered galaxies beyond the Milky Way, our understanding of the universe changed dramatically. When scientists found planets orbiting other stars, entirely new fields of research emerged. Unexpected observations frequently become the starting point for deeper understanding. The James Webb Space Telescope may be providing another one of those moments. What makes these discoveries especially important is that they relate directly to our origins. Everything around us traces its history back to those ancient cosmic events. The atoms in our bodies were forged inside stars. Those stars formed within galaxies. The galaxies themselves emerged from structures that developed in the early universe. Understanding how quickly those first systems formed helps us understand how everything that followed became possible. Perhaps the earliest cosmic era was more dynamic than we imagined. Perhaps stars ignited across the young universe in powerful waves of activity. Perhaps galaxies assembled rapidly in regions where gravity concentrated matter with remarkable efficiency. Or perhaps there are processes still missing from our current models. The answer remains unknown. And that is exactly what makes the discovery so compelling. The James Webb Space Telescope has not revealed that physics is broken. It has not shown that everything scientists believed was wrong. Instead, it has done something far more valuable. It has identified new questions. Every image Webb sends back expands the boundaries of human knowledge. Every observation provides another clue about how the universe evolved from a hot, dense beginning into the vast cosmic landscape we see today. Beyond the galaxies already discovered, countless others remain hidden in the darkness. Their ancient light is still traveling across space. Some of it is reaching us only now. Future observations may confirm current theories. They may modify existing models. Or they may reveal entirely new chapters in the story of cosmic evolution. Whatever the outcome, one thing is certain. The universe continues to surprise us. The deeper we look into the cosmos, the more we realize that its history is richer, more complex, and more fascinating than anyone imagined. The James Webb Space Telescope has only begun exploring that history. And if the earliest pages of the universe already contain unexpected mysteries, the chapters still waiting to be discovered may be even more extraordinary.